Very much welcome to our blockchain and IG session. I believe we have started. Today's session is going to be quite entertaining, to tell you the least. We have chocolates here, and I made sure we bring in local chocolates from Kalev. Is that the company that's quite famous here with chocolates? And we have stickers here. We have the miners that's been predefined, identified here. Anton, Arvin here, and maybe we can be joined by other miners who wish to participate in the game. Don't panic, don't worry if you don't know math. This is not going to be a math test. It's not going to be too complicated. The aim here is to simply explain to you what the blockchain is all about in a more pragmatic, simple way, illustrating how hashing happens. And we'll be using a very simple logo for ours today. We call them yummy coins. Yummy, like this. So today is the yummy coin blockchain session. Based on that, then after we had explained how blockchain works and how these I think there'll be plenty, and there are a couple of seats available if you want. And once we explain what blockchain is about, then we move on to the more, let's say, core cases of the IG discussion itself and why it's important to relate to that. So without further ado, I'd like to introduce the presenter who will be giving us a very brief presentation of 10 minutes. It's Ken Hansen, if you're familiar with the Blockchain Roadshow. Have you been to the Blockchain Roadshow before? It was last at ICANN in Copenhagen. So he is joining us remotely, and I believe we are having him connect with the video as well. Obviously, of course, I didn't mention my name is Walid Al-Sakaf. I'm a board of trustees member, but I'm here in my capacity as a blockchain enthusiast and a person who'd like to explain the technology. So if we have Ken, then we'll give him the floor so that he can present what blockchain is. So it's your floor, Ken.
Great, thank you, Walid, and thank you to EuroDIG and all the attendees for the opportunity today. I'm going to take you very quickly through a high-level overview of blockchain. I'm sure there are some of you in the room who know about blockchain and some in great detail. Don't worry, when we get to the next exercise, we're going to get into a lot of detail, and we're going to make it fun as well. So what is blockchain? If you ask 10 people what blockchain is, you probably get 10 different answers. There's a lot being written in the media about blockchain, but let's take this definition. This is a definition from IBM, and there are several key terms that are mentioned in this definition that are fundamental to blockchain. One is the concept of a distributed ledger, and we're going to walk through what a distributed ledger is in just a moment. But essentially what it means is there are nodes, multiple nodes. There are complete copies of the database and the transactions in the block, and the entire history of the block in every one of the nodes. The records in a blockchain are what some call immutable. They're permanent and they're tamper-proof. They cannot be changed, and they're time-stamped as well. Blockchain is a peer-to-peer technology that doesn't require any centralized third party. So I'll go into somewhat of a description of what that looks like. But one thing to note is there's no central party in the middle controlling everything with all visibility to all the transactions. What you're looking at now is the white paper first published by someone called Satoshi Nakamoto in 2008. This white paper described the concept of a blockchain for the very first time. Nobody knows who Satoshi Nakamoto is. He's completely anonymous to this day. He hasn't been identified. In 2009, he generated the first blockchain Bitcoin transaction, the first block that's referred to as the Genesis block. And the value of the Bitcoin that he purchased in his transactions, he owns 1 million Bitcoins. In today's Bitcoin value, that's worth over $2 billion. He's never withdrawn a single Bitcoin, and to this day, he's completely unidentified. But it's this white paper that described how a blockchain would work. Primarily in the case of this white paper, primarily in the context of cryptocurrency. The major problem that this white paper and blockchain solved is a problem called double spend. In the real world, if I give you 10 US dollars in paper money, I can't turn around and give the same $10 to another person. But in cryptocurrency, the problem that had been unsolved until this white paper is if I give you some bits, some ones and zeros that represent money, currency, what is to prevent me from turning around and giving those same ones and zeros to somebody else? That's called the double spend problem. We'll go into how blockchain solves that double spend problem in a minute, but this was really what is behind the revolution and all the excitement around blockchain. For clarification's sake, Bitcoin is not synonymous with blockchain. Bitcoin is an application that runs on blockchain. There are many applications that run on blockchain. Not all of them involve cryptocurrency. In fact, most of the applications that run on blockchain don't involve cryptocurrency. And the other thing that I'd like to note is you often hear the media refer to the blockchain. Well, there's no the blockchain. There isn't one blockchain. There are many, many blockchains. At this point, I would estimate there are at least hundreds of blockchains, maybe even 1,000 or more blockchains. Because remember, blockchain is essentially a P2P technology. It's software. There's no single centralized blockchain network. So what is a distributed network? You're probably all familiar with a centralized network. Everybody is connected to a centralized server. Then there's something called a federated decentralized network, and then essentially you have star networks that are interconnected with one another. But a distributed network is an any-to-any network. It's more like a mesh type architecture. So how does a distributed open ledger work? First of all, there's no, as I mentioned before, no centralized third party. So let's quickly walk through how a transaction works in a distributed open ledger. We're using Bitcoin as an example here, or cryptocurrency as an example here, but keep in mind this can be anything of value. It can be ownership of land. It can be a bond. It can be anything that has value. It could be a shipment of goods or services that are moving from a manufacturer to a retail store. But let's use cryptocurrency in this example. So let's say A wants to send $5 to B. So A sends $5 to B. A starts with $10. He sends $5 of that to B. Now what you'll notice is every one of these nodes has a copy of that first transaction, A to B, $5. So there's a copy of that transaction in each of the nodes. And then B sends $3 to C, same thing. There's a copy in every single one of the databases. In the case of Bitcoin, for example, there are over 600 nodes at the moment. So every single Bitcoin transaction that's ever taken place since 2009 is in every one of those 600 nodes. So then C sends $1 to D. So that's in there as well. Now let's say A tries to send $15 to D. Now all of the nodes know that A no longer has $15. So that transaction would be rejected. Okay, so that's a very high level basic transaction. Now, in order for that transaction to take place, you have to have what's called validation or consensus agreement that the transaction is indeed a valid one. So you've probably heard of something called Bitcoin mining or a mining node. And in the case of Bitcoin, it uses a consensus method called proof of work to validate transactions. So within the Bitcoin blockchain, there are special nodes called mining nodes. These nodes work to validate transactions before they're added to the blockchain. Now let's walk through step by step. So a transaction is sent from any one of the nodes on the blockchain. The first thing that has to happen for that validation to take place is a mining node needs to solve a cryptographic puzzle. So that cryptographic puzzle is sent out to all of the mining nodes. The mining nodes work to solve that problem. In other words, to find the key that solves that cryptographic problem. Once one of the nodes finds the solution to the problem, it broadcasts that solution to all of the other nodes. All of the other nodes then add that block to the chain. So now you have a valid transaction. It's been synchronized and sent to all of the nodes, and now all of the nodes will start looking for the next puzzle to solve. The node that solved the problem will receive a reward for being the node that validated that transaction by solving the puzzle. Because it takes a lot of processing power and a lot of electricity to solve the cryptographic problem, and you need to incent the nodes to validate transactions. They receive some Bitcoin as a reward, as well as a transaction fee. So that's kind of step by step how consensus works. This methodology of achieving consensus is called proof of work, but there are other methods of consensus as well. For instance, there's something called proof of stake, which is based on what percentage of the total currency does a particular participant own. So that's a basic step-by-step transaction, again, at a very, very high level. What are some of the use cases for blockchain? I said before, in addition to cryptocurrency, there are many other potential use cases for blockchain. So this is just a sample of some of the applications. So the first one on the top left is something called Open Bazaar. So Open Bazaar is an e-commerce application, somewhat like Amazon, but the difference is there's no centralized party, no centralized marketplace in the middle. So each of the participants in this marketplace downloads the blockchain software onto their laptop, onto their computer. And once they've done that, they're able to list merchandise, products for sale, and sell it to other participants in the network. If that participant, so they essentially open a store, and then they can transact with anybody else who has the software on their computer. All payments are made in Bitcoin. If they turn off their computer, their store is closed. But again, no centralized third party. So that's one application. If you took a plane to attend EuroDIG, this next application will be of interest to you. This is an insurance application. Some would call it a betting application. And what this application does is it pays you a fee if your flight is late in arriving at its destination. So before you take your flight, you would buy this insurance, and you would essentially bet my flight is going to be 30, if my flight is 30 minutes late or more, I want to receive this payout of X dollars. So you pay a fee that's of course lower than the payout. And when your flight lands, the blockchain has a third party feed that records the arrival time of that flight. And if the flight was late more than 30 minutes, you would be paid the fee. You would be paid the insurance payout for your flight being late. Notice a few things here. First, it's completely anonymous. So you don't need a credit card. You don't need to give them your name, your address. All payment is made in cryptocurrency, and it's automatic. And irreversible. So once they enter into what's called a smart contract with you, that says if your flight is late more than 30 minutes, we're going to pay this fee. When the feed indicates the flight is late, it automatically triggers the payment. So you can have confidence if your flight is late, you will receive the payment. That's something called a smart contract. Also a very important concept in blockchain. Essentially, smart contracts are code that reside in the block, in the chain, in a block in the chain, and there's a copy of that application in every single one of the blocks. I'll go through one more, which is something called Ripple. Ripple is for international money transfer. We all know that international money transfer can take, in today's environment, typically takes several days to complete. And it can be expensive, $25, $40, even $100 for a single transaction. Using blockchain to transmit money from one country to another takes seconds and costs pennies. Ripple is providing this capability to banks who wish to provide their customers with fast, almost real-time money transfer at a very low fee. So those are three examples, but there are three others listed here. There's one for real estate, supply chain, healthcare, but there are many, many more. So that's a basic overview of blockchain. I look forward to any questions you may have later, but for now, I'll turn it back to Waleed and the team, and I know you're looking forward to the game, the exercise that you'll participate in later, where you'll learn a lot more. Thank you very much.
Thank you, Hanson. Ken. So, are you ready? This is the moment of truth. Now, and so as not to get too harsh on you, we have not really, we're not going to assign volunteers randomly. We will ask you to volunteer. So we have asked a number of colleagues of mine who are already willing to volunteer. So what happens here is that, as you know, you might know in the blockchain world, there are traders. Traders meaning people who send and receive Bitcoin or blockchain coins, whatever they are. And then there are miners who are doing the proof of work, who do the verification of transactions that traders do. So here we have a number of colleagues. Each one, I asked them to introduce their wallet address. A wallet address is the location where you send money to or coins to. And these are our coins. They are Yummy coins. Each one is one in unit, and making it simple. And we have up to, I think, 120 coins in this. And what we'll do is that if you volunteer, you will get free from us 10 of these already from the very beginning as a gesture because you've shown courage. And so we have Anton and Krishna. Anton is number 4.
Yeah, number 4. I'll put the names on the tables.
Yes, exactly. Number 4 is the wallet address, so you send coins to if you want to. And number 1 is a miner, and he's also a miner. Are you a miner? No, a trader. A trader, yes. So Krishna will be a trader, and his address is 1. He won't mine. And then we have Fabian. Fabian, who is number 9. And you'll start off as a trader and then become a miner if you're interested. All right? And then we have Arvin, who is number 2, and he is a miner. Exactly. And so these are already here. But now we have 5 more slots. So I'd like anyone to volunteer to become a trader or a miner, depending on the level of expertise he has. If you're willing to be a trader, it's very simple. All you need to do is simply say, I want to send coins or yummy coins to number so. So any hands, show of hands? There we go. 1, 2, 3, 4. Okay. So I'll be giving you your number. Yeah, basically what I've done is simply assign the wallets and the wallet address, which is the number, to the Yummy coins. So now you are part of the network. Individuals who have numbers are now the blockchain. I mean, their nodes are part of the Yummy blockchain. So what we'll do next, and maybe I'll use your help, to pass this around for every single node to get 10 of these as their capital. Now you will get 10 Yummy coins as your capital. What you can do is that you can trade these, just like you do in the real world. In the blockchain, you trade your bitcoins. Now you'll simply trade them by sending them, or you can receive bitcoins from others. The fact that you are able now to help us construct the blockchain from scratch. Okay, let's see. No, that's okay. So now that you have your coins with you, the pot will remain back here, because that's where we will use the resources we have, the pot, to send rewards to the miners once they do the verifications. Okay, so we have 2 miners, apparently. Actually, is there anyone who's really interested in becoming a volunteer also? You want to be a miner? Okay. So I warn you, it's going to be competitive. Okay, number 3. So miners need to have equipment, but they need to be fast. And proof of work means that they have to guess any answers to questions very quickly. So I'll ask the miners to stand up and come over to the boards. All right, let's see. I think you'll add your names. So who is not missing on this sheet? Yeah, you can add the names. And I suggest that you remove this and put it somewhere here. We can tape it on the wall. Yeah, take it out and tape it. Yep, come. The miners need to be active, you know. You didn't know that? Now you're stuck. I'm sorry. But it's, every reward needs some risk, so you need to. You don't know what you put yourself into. Okay, so you use this. Okay. So now we have a very good basic infrastructure. We have coins that have been distributed. We have miners in place. Here, it's defined in this note here. Can you help? And you have traders. We have 9, I believe, because that's the limit we have for today. Otherwise, it could have increased. And now the main exciting part is that now any of the traders or miners would like to send to some other person on the blockchain some coins. So who is willing to send to whom? All right, then Fabian will be sending. Okay, just let us know how much it is and to whom. Okay, so now we have, can you put the rules on the, so there is a very simple rule. We create a transaction code, a transaction hash. This transaction hash is basically an illustration of what you have on the blockchain as an unverified transaction. So the way it works is that at the very top right, can you zoom to the very top right where it says transaction up there? So we have the timestamp, and timestamp right now, can anyone tell us the minute timestamp? What's the time? 24. 24. And then the sender is number 9. Recipient is number 5. And the coins you'll send are how many? 3. And how much in transaction fee do you want to give? If you want to give 0 or 1 or up to 9, how much do you want to give miner? 1? Okay, that's stingy, but it's okay. Okay, to start with. That's the first transaction. So who's else willing to send money? We need at least 3 or 4 transactions to start working. Yes, how much will you send? 5. So is it 24 or 25 now? 25. And it's number 1 to sending
6.
To sending the number 6, who is Valentina. And how much is it? 5 you said? 5. He'll send 5 coins, yummy coins, and fee is 2. All right. So we have 2 unverified transactions. Okay. It will help. My hand is aching. You know, I've been working all day to prepare for this, so bear with me. And so what is happening right now is basically we'll need to start the process. Multitasking, I said. We'll need to start the process of what we call verifying transactions. Okay. If these are the 2 transactions we have, we can start with them. But we have 3 miners, so what that means is basically at least 2 miners will compete for the same fee, for the same transaction, which is good. So right now, these are unverified transactions. In a blockchain, in a Bitcoin, you have people sending and then expecting the miners to begin to verify these. So we have 2 unverified transactions, and we have the miners ready. They are, okay, there's now the, okay, now it's working. So now the unverified transactions will begin. We need the miners to now tell us which of the transactions they will want to verify. Okay, come over and make sure that you let us know what you point to the one that you'd like to verify. Maybe you can write your number on it as a between brackets so we know who is working on what. Okay, you can use the pen, the markers down there, so for clarity. All right, so can you explain to us your rationale, why you chose 2?
Because it's the biggest reward for me as a miner. If I solve this hash, I can actually have 2 yummy coins.
Plus the reward, excellent. And so why did you decide on the first? Just want to make the blockchain work, right?
Because I don't want to compete with the other.
Wow, that's quite wise. Anyway, so what this means is basically...
Who appear to know what they're doing.
So what's going on right now is that we have 2 miners trying to verify this transaction because they'll get 2 coins as reward, yummy coins, and she will get 1 if she solves the blockchain, the puzzle. So now we come to the exciting part of trying to know what question you'll answer. So there is a formula for this. This is basically to calculate which question you will be getting. So I think that's which part, which step is it?
Down.
Yeah, so if you can go a little bit further down. Yep, that's it. No, yeah.
Here's how it's sketched.
Exactly, quiz. So what happens here is that based on the transaction, they will get a number. So each of the miners will calculate the total of digits of their transaction. So please calculate the total digits, meaning that You take each of those digits and then add it to the other next to it until you get the result. All right, you're a good mathematician already, 25. You can verify, it's simple to verify. Yeah, so 24, correct? And the second one is 21, correct? All right, so what happens here, based on the rules of this blockchain, the last, say the last digit, since the number ends with the number 1, and for you it ends with number 4, so you will have to go for the colors. So the colors here, pink, is number 1, it was within the pink color, as you can see in the table. So you'll have to get the first question from the pink side, while on the your answer is 4, so it's within the yellow, so we'll get a question from the yellow side. So I'd like now to have each one of you open up the question and read it out loud. Read it together. Yeah?
Approximately how many Estonians can fit into Sweden? Area-wise. So it's usually a guessing game, so that's why.
Okay. And so your question so that we can.
Share your Google. What was the date in May 2000? What was the date in May 2017 when Bitcoin's domination of the cryptocurrency market fell below 50% for the first time?
Okay.
And why is there a number at the end?
Because the number is basically the range. I'm making it easy for you to estimate. So I'm giving them 11 to 16 for her, and you have from 7 to 12 for them. So right now, on your marks, get set, begin writing your guesses right now on the board, one after the other. Got it.
Oh,
So, yeah, so, and you? You need to write down, write it with a marker so people can see, actually. We can't see. So write it. Oh, okay. You got them? I'll see. The answer is, yeah, you got the answer. It was 15 here. And so we got it there, and then it was 10 here. So what it means is that in this case, Anton won, and so we stop here. Anton won this particular block, and of course you're the only person, so you won your block. So congratulations. So that means, yeah. So why it happened is that he guessed very quickly. And so it was 10. This is simple because there are just few to guess from. But what happens as time advances, the number of the scale or the number of guesses that you need to have is much more. So right now, what will happen is that we'll create the block. So they started, they were first, and so they will be the first block, and yours will be the second block. That's how it works. Both of you will be rewarded. Then what happens here is that we'll go to the next stage in which we have more blocks to mine. So right now, this is the rule says that if you go down, is it up or down? It says that the mine hash is basically the miner's name. So you can write down the miner's name, your address, and your miner address is number 3. Did you put it somewhere? I have it.
It's there.
You should have it on you. Okay. So what happened now is that basically we have the first mined block. This is the first mined block of the blockchain. It's after the first very initial block, which is the genesis block. We call it genesis block because it's zeros. So this is based on the numbers here. You see that the winner is 4. That's the miner. And it's verified. Every single person within the blockchain has the same number. And this is a transaction that's been verified. So, and you have 3, 2, 4, 9, 5, 3, 1. Okay. All right, so what we can do now is we will give the chocolates to the reward, the winner of the reward, as we have, I believe, 5 per reward. Every single block that's been mined will get 5 chocolates. Plus, the recipient and the sender now will complete the transaction. So the yes, the ones that will be sent, and they will be received, and the fees will be given to the miner. So now the yes, and for you, you will get. So if you remember here, in this case, we had 9 sending to 5, 3, and there was a transaction fee of 1. All right? So you need to get 1 plus the 5 for your block. So, no, from him, from the transaction. 1, 2, 3, 4, 5. Why am I using this? Okay. 1, 2, 3. All right. So, and this is your reward for the block. Because this is the reward for block mining. Yes, for mining. Yes.
So anyway, I get money for mining.
Yes, you do.
I do it right or wrong?
No, you got it right. You did it. Eventually, you guessed the right number, which is 15 here.
Yeah, but what if I didn't guess right?
You will lose. No. Yeah. Actually, yes. Please.
I would like to complain.
Yeah.
I should have received 5, but I only received 3.
What was your number? No, your number is 5. So 9 sent to 5 3 coins.
Oh,
Okay. It's on the blockchain. All right. All right. So you didn't get yours. You have to get yours. It's not an issue. People are watching. All right. So now what happens is that we have finished the first block. So blocks. We need to put in the block's color, which is basically the total of the transactions. Did you calculate the total? Not yet. So we need to calculate 35. The totals. Yes.
35.
All right. So this will lead to the new hash, which is 5. Okay, yellow. And so yellow is the new block. So it will be on top. And it has a hash. What's the hash?
The hash I have to add zeros.
Yes.
Number.
So it's the same. Exactly. So what happens here is that every block has a hash number. All right? And the hash number is basically the block, the total of the block before it. And they are the first. So Genesis block is zeros. So it means that they have this as their hash number, the hash code. And for you, you'll be the second block. And so what happens here is that your hash will be their hash plus yours. So you need to add their hash to yours, meaning that you need to add that number, not the whole thing, the whole hash. You can copy this. This is their hash. Copy it. Help. Yeah, help. So, all right. So now add these together. You will, and I mean the total of all of these 2 digits together. So that's what I said. Our calculators did it. So this is to explain to you that if you have a new block on top of another block, so it has to connect to the earlier block. So it means that the hash code for the new block is reliant or dependent on the hashtag of the earlier block. And that's how the blockchain begins to become connected to each other. And the other problem here is that you notice that there's only 1 transaction per block. That means that that's the speed as what we're going. In reality, every block has several transactions. In Bitcoin, for example, it has 1 megabyte of transactions. So now we have the winners. Everyone's got theirs. We have the blocks one after the other. The total for that, what's the total for your hash so that we can get the number? 25. 5 is yellow. So now we have the second block is supposed to be yellow as well. So we can write down the number of the blocks here. This is number 1. This is number 2. So now we started creating the blockchain from the very beginning. We have two transactions have been verified. Now what happens is that new transactions need to come about. So more players need to send coins. So who's willing to send?
I sent 4 to James, to 7. 5 and 3 to 7.
All right, so. Okay, so now we have new transactions. There will be a transaction from, your number is? 5. Yeah, and 38 is the time. Now, to whom first? To whom will you be sending it?
7.
To number 7. And how many coins?
5.
5. He will be sending 5 coins. And what is the fee that you will pay the miners? 2, okay. All right, this is one transaction. Who else would like to send? Yes, you can, of course. You're all right. So, okay. So now what happens is that he's raising the fees so that he gets his first. He wants his process to go first. This is what happens when you lower your fees. You lower your transaction fees, you get it much slower, and the miners won't be interested. If you do not send any fees, and this is possible, you might never get your transaction verified. So that explains why fees play a role in speed. Another issue is that if the block size is bigger, then you can have many more transactions done at the same time, because all they need to do is just one puzzle question. But if the blocks are smaller, so every block has only one room for one transaction, so you need to have every single transaction will require a new block, which means that it takes also longer. So now we need more transactions this time, at least 3. I didn't get your question.
Can you use the mic?
Yeah. Can you use the mic?
Is it possible to put multiple transactions in the same blockchain? And does it need multiple fees, or it can take only one fee?
No, you need multiple fees. Every transaction needs to have a fee, but you can have as many transactions as you want, as long as you have the money, because some people might, it's not possible to send transactions that don't have coins to cover for.
So every transaction is a fee?
It's exactly, yes. And so we have here more. All right, so we have 3 transactions. It's 3 different transactions. So
How many coins, so I can't send them?
you have lots of coins. All right, so do you want to send him coins? All right, so time now is how, 41 already?
What if I do the same?
40? 42. 42? 42 is the minutes timestamp, and then your number is 3. And his is 2, and you're sending how many coins? 3 coins, and the fee is 2. Okay, quite a heavy fee compared to the. All right, okay. So what will happen now? You should have gotten 10 actually, at the very beginning. All right, you should get 10, because then you didn't start with the right capital. Okay, so take the 10. Your 10 should have been given to you. 5 in transaction?
I have many.
Okay. Okay, that's unusual. Make sure it's 10. Count them. So.
By the way, what just happened is called hard fork, but
It's not really useful to have the miner take directly from the pot. Anyway, so now we have 4 transactions, and we have miners to compete. So which of the transactions will you take? Of course, the last one, so that gets, cross. So Anton, will you?
Just one clarification. You're sending 3 with a fee of 5.
Yes. Unusual. Okay. So you want to mine.
To mine the 5 transactions.
Okay, Krishna is going over to mine. Okay. Fantastic. The others, you can, but it's gonna be complicated. You know, you need to guess more the answers to multiple questions, which doesn't make good sense. But you know, you're free. You can do whatever you like. What do you want to do?
Because nobody wants to mind the others, so I'm going to mind.
You can compete on. All right. Which one will you go? You're going for the lower fee. That's not just justified. You need. Okay. What about the third? It's also 3. So why did you choose 2 over 3? That doesn't make sense. All right, you're free to do whatever you like. In reality, this is not really irrational because you don't know the transactions' whereabouts. There's no favoritism in the real game. You just go for the highest fee. Any case, you're taken to. You can change your mind if you wish. Okay. Yeah, and remove it from there. And this is a good lesson. If you have lower fees, you will never get across. So now that person with unverified transaction will remain unverified for this round. So add up the numbers quickly so that we can go for the quiz. Everyone add their numbers.
Yes.
The miners need to start working.
I decide. Number 9. What is this transaction? Can I have a question for number 9?
Okay, you're already 9. Okay, let us wait for them to 9 also. Okay.
That one is 9, yes.
It's the same. And so get the total for the other 2. All right, 6, 16. So the last digit is 6, and 8. So now go to the map. You see 8 and 9 are green. So this means that you have multiple questions to ask. So the first question is by everyone. So it will be.
I will need the help from a committee, steering committee. How many workshop proposals were rejected by the IGF 2017 screening committee?
Okay. All right. They already have been decided. All right. So this is the question. And give us the range of answers.
From 9 to 14.
9 to 14.
That's it.
So start. Go. I mean, you have the top 3 question. Oh, let's.
Nobody has to question.
So that's the yellow, and you've come across. I'm faster than I am. So 2. So where are you at? What's the range again?
9 to 14.
So we all guessed everything.
And it's the green.
In this order.
Yeah, the green. You guessed everything. So we'll just see who got there first, because.
I hope it's not 12.
All right. So yours is the first because it's 13. So stop. Salam, you've lost this transaction. They got. All right. They are the ones who won, and so Arvin is the one who won. So now he gets to be the winner, and now he'll have the new block with his transaction verified in the next block. So now calculate the total, get the number, put it there. Miners, quickly.
I don't have to do it, right? Because I lost.
You lost. Yeah, you can go home. Yeah. You used power at the effort and didn't get anywhere. So this illustrates how.
He worked on the third,
Yes.
on the fourth transaction.
Yes. So, but now since we have a block, let him finish the block because he won and you lost, and so that means that this block is his, and so we wait until the next block gets mined. And no, you don't return the. That's it. It's gone. Yeah. I mean, this gets disposed because you couldn't. You failed to get anything by the time.
So are you saying that the network is going to decide which transaction to do, which transaction to do? I thought that blockchain network, he has to do everything.
I mean, blockchain is us. Blockchain is us, and the nodes are the blockchain. So there's really no central authority. So what happened here is that because you didn't really win this round, the questions will be dropped, and then we move on to a new question. So now, if you want to do it again, you can do it again, any of these, and then get the next more difficult question. Your time will be that you have now 8 and 6. 8 is green, and you can also have 6, depending on what. That's what I said. You can't do multiple things. It's like difficult. So, but if you want to go for 6, 6 is yellow, And you can take the next yellow question. But let us finish now, to be fair, for them to get their block. And that took you so long.
Sorry, I didn't realize it.
Oh, yeah, so to,
Hash, okay.
yes.
It's
So
number 2, that's me, solved the transaction which was,
2 is the winner.
yeah, and 42 was a tie.
3, 2, 3, 5. Fantastic. So this is the transaction, and after you add the winner, and now you multiply that, and okay, you add that to the last hash. So where's your calculator? You need to add it to the last hash on the earlier. Now you have you remember the last hash? Yeah. No, it's this one. So this is your, okay, so this is the last number, this is the hash for the last block. So you need to add that block, that new verified transaction, to the old
Walid,
3.
Ken is asking us if we have any questions for him before he drops.
Any questions, or do you want to? No, I think he can say goodbye. And so, thank you. And so we have the total here. Just remember, as he adds these, remember that now this new block is also dependent on the earlier block, and it's dependent on the earlier and the one before that. So it's like intrinsically linked. So every new block is reliant on earlier blocks. So we learned several things now. We learned that transactions with low fees will not go through because miners compete for the higher fees. You learned that blocks are created by the winners. The winners are the ones who create it. And so this is the total for these digits would be. And in reality, anyone on the node will have to actually verify that the count is correct. I mean, this is in reality. Of course, if you're not verifying, that's nothing. So green. So now we have a new green blockchain, a block in the blockchain. And so this is your block, and it's number 3. So now the blockchain is continuing. We have information about what happened on the network. And so now we finalize the transaction, which is giving the first the reward, 1, 2, 3, 4, 5. This is yours.
Walid?
And then you get the fee. She is giving him, she gave you, or no? Yeah. No, who is the sender? Yes, it's yeah. So 3.
Sending to me.
Walid?
Yes. Ah, in terms of time, okay.
We're 8 minutes till 6.
All right, so. So we'll do one more block, and then we will do one more block, and then we'll move on to the next stage, just to explain that this is going on. So now what happens that we have a transaction, so they'll need to compete now on the remainder, or if new transactions are sent, they will be verified. So any new transactions to send from the current you'll be sending? Yes, we have 8. So 6 will be sending to 8. How many coins?
5. 4 or 5.
Okay, so now what's happening is that number 8, which is Dordid, is sending, number 6, sorry, is Valentina is sending to Dorde 5 coins, and the miner will get 5 reward coins as well. So that means that the miners will probably take that one right now. Yeah. So who are the miners now? Are you still in the mining business? Okay. So, all right, start. Did you add the numbers? So what happens now is they'll add all the digits to get the number. 10, 18, 32. Fantastic. So 2 is the color pink. So we'll go for the second question. And if you read out loud the question, please.
What percentage of the Estonian population died because of a hunger in the late 17th century?
Percentage of the population.
13 to 23 range.
All right.
So,
Very quick.
17, 16.
Ah, she got it. She got it.
Okay.
I don't know how fast. I saw her before you, so I'll give her credit. You know. It's okay. You know, I mean. I guess. No, she got the 20 at the end. So. Yeah, any case, she won. Let's say, for sake. Yeah, 20%. Exactly. So that's some general knowledge for you guys. Yep.
So you said there is no central authority, but you're acting as the one?
No, it's not. I'm simply implementing the rules. I'm the processor.
You're the good.
I'm the processor because otherwise it's. So now you get the 5.
So your number was 3, and you saw
So in reality, obviously, the timestamps will be compared. Okay, so
5, 3, 6,
Yeah,
8, 5, 5.
okay, if anyone is interested, this is an interesting thing we can do. If the nodes here think that he won, then you will then verify his block, even though I said that she won. This is still possible. In reality, blockchain, if you have two miners who win at the same time or think at the same time, then voters will decide, the actual nodes will decide which block to extend, which block to use. Yeah, so you can still win theoretically if the nodes decide that it's your block that they would like to approve. That's how it works. Yes?
Well, in reality, I'm running into a problem because my transaction should have been honored and it didn't.
Yes.
And now I have two choices. Either I leave it like that or I increase.
Yes.
Can I do that?
Yes. You can increase your transaction fee.
Can I increase the same or do I have to withdraw first and re-enter?
You can add a new transaction with the new sender, new receiver, and then use that to send.
How do I nullify the first one because I don't want to pay twice?
I think there is a mechanism to do that on blockchain, where Bitcoin, where you nullify one transaction if it's not verified. But
So the blockchain is infinite now. How many blocks are there in the blockchain today?
I mean, as of now, I don't know. It's the 200 gigabyte of data already. I think 200 plus the Bitcoin.
You have to specify which block.
You mean Bitcoin? Ethereum? Ethereum is lower than Bitcoin. I'd say around less than. Bitcoin is about 200 gigabytes. So you need to download the blockchain, all the blockchain to your drive if you want to.
600 nodes have 200 gigabytes.
No, not 600. 600 are the individual nodes that are verified, that are having the duplicates, but it's not the number of blocks. The number of blocks is way more.
Don't they all store?
Yes. They have the duplicates. Each one has 200 gigabytes of data on their device. Yes, 600. And so did the sender and receiver reconcile everything? You know, I do not want to intervene because, sorry? So the sender is,
we just worked on one transaction.
yes, we verified one single transaction. But yours, that was, that's not, Valentina, no, it's the new, you mean the new transaction.
She has to pay 8. Number 8. She has to give me 5.
Yes, so it's still continuing. So we have, yes, so the reward needs to be given, is you get the reward, and now the transaction needs to be complete. So she did send you, did she? You get the coins? All right, she needs someone to help her out. So what happens now is that we have one more block, and this block is verified, and we know the winner. The recipient received the coins, the sender sent the coins, the miner got their coins, and this blockchain is actually duplicated in every single node that exists on the network. So everyone now understands what happened in the history of the blockchain. Yes. So there's one scenario. Let's say he was about to receive, and this happened. Okay, you were about to receive it. And excuse me, can I see this? Thank you very much. That's mine. And now I stole his private key. I stole his private key. He was reckless. He couldn't really protect it. So I simply went into his system and I stole the private key. So now I simply pretend to be him, and I actually can take his money. And I can take his coins. But it's hypothetical, so don't worry. So I think that this more or less summarizes what we are about. This is how transactions take place. You have miners who compete to answering questions. We have nodes that send and receive. We have transactions that don't get fulfilled. They're quite slow sometimes because there are not many in one block. And we have a process that makes sure that every single new hash is reliant on the earlier hash. And so this keeps the network intact. It keeps the hashtags connected. Yes?
Is this slide available online for download or for
yes,
later?
This will be in the report once we finish this workshop. And excuse us for any lapses. This was the first ever experience for us to do it live in such a fashion. So I thank you very much for participating in the game. And so each one of you will get the remainders of these coins. We will circulate so that everyone gets another number of cycles. And while we do that, we'll move on to the next stage, which is basically the discussion. Now we understand what blockchain is, how it works, how miners work, which is called proof of work. And now we will move to the actual IG discussions. Yes?
Something I didn't get is the quizzes. Where do the quizzes come, the questions come from?
Okay, I mean, that's a good question. In reality, these quizzes obviously are fabricated by me, but in reality, answering questions is basically being given a particular hash and a particular, let's say, code. And then you will be asked to get the original content that resulted in the hash. So that means that you'll have to go randomly through a huge number of guesses until you get to the right hash. That's how mining works. And it gets more complex as more miners join. And so you will notice that complexity increases as more miners join.
So the one who has the best algorithms for guessing makes the most transaction money.
Yes, but you can answer that one. Yes. It's proof of work.
So the idea is to use some cryptographic tools that make sure that there's no better algorithm of finding these answers. The only way of finding these answers is just by trying the entire set of possible answers and then guessing, checking if it's correct. No, the next one, the next one, the next one. And therefore, the only way to proceed with this kind of mining is to implement this algorithm in more and more efficient way, like in hardware and in some specific hardware. That's why we have a specific industry of specific hardware of mining bitcoins.
Yes. So I know that we are a bit behind schedule, but that is worth it, I hope. And you got chocolates at least, that's a bribe. And so we move on to the next stage of discussing, okay, now that we understand technology looks like it's self-sustaining, it's peer-to-peer, decentralized, distributed, and it involves proof of work, it involves verifying, etc. So now we would like to know, what are the implications on internet governance, and how does this play out in the real world? So I believe we can begin with asking Anton, perhaps, giving us the perspective of how does blockchain technology enhance trust on the internet. So you can take it from here for another 5 minutes. And you can introduce yourself, of course.
My name is Anton. I work at a startup. We try to develop the distributed systems based on blockchain technology. I would say that there is kind of confusion what blockchain is, as Ken mentioned in the beginning. If you ask 10 various people, they would give 10 different answers. My personal view on blockchain technology is that decentralized system, that the system that could make sure that there is some kind of shared protocol that works between the participants, but each participant of this system could still retain its independency. So it's kind of trade-off between fully centralized systems like cloud, which is centralized in the hand of Google, Amazon, or completely decentralized systems like the internet we have today, and the only thing, the only protocol is the protocol of communication. There's no protocol of validation of data, and something like this. The blockchain technology, there is lots of similarities between blockchain technology and the internet itself, in the sense how it has been created. I see that that internet has been born as a system that is decentralized from the very beginning. That there is no there is no single body that controls the entire internet. And the same is true for Bitcoin, the same is true for other blockchain. There is no single authority that could change entire blockchain just by wishing so. And therefore, this kind of similarities, they establish this relationship between blockchain and internet. That blockchain could be also seen as the next, some people say that the blockchain is the next iteration of internet. I'm not quite agree with the definition, but the truth is that we have the network and we add the logic to the network. We add some code, we add some something that can be executed in addition to the existing infrastructure of data exchange. And that's how blockchain and internet are closely related. And blockchain today is in a very early stage of development. And there are many of blockchains which are not covered by any standards. So, and probably in next 2 years, the question will be raised how to make common standards of the data exchange between the existing blockchains. Yeah. And probably that should also be the initiative of internet community to take lead in solving this problem.
Thank you, Anton. And so in summary, what is said now is that since there is really no intermediary, there's no third party involved. You have end users communicating with each other. That builds a network that does not require to trust a particular central authority. It doesn't require you to trust your bank anymore because transactions are done through math, pure math, that's verified by everyone on the network. And that leads to more of a, instead of using the word trust the network, you can say it's become a network that requires no trust. No one needs to trust anyone else because everything is built on the code that is pure math. And so that's perhaps the notion mentioned here. Yes, please. There's a mic here that you can use.
It's right in front of you.
There's also one there.
Right in front of you. To the left. Right. Yeah, your left.
Thank you. Is it working?
Yes.
Yeah, okay. So I think actually you need trust because what you see today in Bitcoin, I remember reading about this Chinese miner, Jihan, who ingeniously found out a hack to mine more based on... help me out, Anton. I know you know about this.
Yeah, in earlier Bitcoin developers, there were quite a lot of bugs, and these bugs were exploited to claim some coins that should not be normally claimed.
Yeah. So you have a really important player, a really important miner, this Chinese Jihan, who has the power to manipulate the transaction and what's going on. And if I know this correctly, he's one of the players that is stopping the transition from proof of work to proof of stake.
Yeah, so, I mean, just because of time, what I can refer you to is the fact that every single code has a coder. So eventually, if there are bugs in the code, then of course the system might not work as expected. So there is an element of trust, but I'm referring to the potential that you have the source code being audited by everyone and everyone agrees on it and understand what it means. So at that point, it becomes trustless. But there is a point in trust at the very beginning when you actually write the code. I think we have other participants on the line. I know that Hanan has been waiting, so perhaps we can give her the word before you. So on the remote participation, Michael, is Hanan available to present?
Yes.
So
Hi,
fantastic.
everyone.
Let's see if we can see you on the screen.
Yes, I will put my camera on. So my nose is a little bit blocked today. Thank you, Walid, for the very entertaining session on blockchain technology and how it's practically working. I feel like I'm gonna put a downer on the session because when we talk about regulatory issues, it's always boring, and the standard here is that technology is quite ahead when it comes to implementing regulation. Now, the trend in Europe is that a lot of countries are trying to regulate blockchain, namely Russia, which recently made a statement that by 2019 they will have a regulatory framework in place to monitor blockchain. The issue here is that nobody knows exactly what should be regulated, and I think we understand why. The technology itself is not mainstream, and we don't know yet what it can do and what it can achieve. When it comes to the European Union, they adopted a more of a balanced approach where they really want to identify what blockchain technology can do before they introduce regulation. But both approaches, anyway, have a set of drawbacks. What we would like to have is to foster innovation and make sure that blockchain can realize its full potential without putting regulation as a first step. I mean, it's becoming now more natural for governments to try to regulate technology in general, but in the case of blockchain, the full potential of this specific technology is not yet known, so it's very hard to speak of any model at the moment which puts regulatory framework at the forefront. I think defining the use of blockchain is a key question when it comes to policy implementation. So we need to know exactly what are we going to regulate. Are we going to regulate the public networks according to the users, or we're going to regulate the what we call the private blockchain, because anybody can develop blockchain. So the predictions that there might be some kind of due diligence that is needed to validate people who would like to develop private blockchains. But to what extent it's going to enhance the technology itself is not yet known. So there are a lot of question marks here. My preference is to have more of an open platform. Like you just did a game and it illustrated how anybody can feed into the chain. And the most important feature of this technology is that it fosters accountability and transparency, and they are very much needed in various levels of transactions, be it titles, financial transactions, land registry. We've seen earlier by Ken many examples where blockchain technology is being used. Of course, it's cost effective, so it's very hard to try to focus now on regulation where we don't know exactly the full potential of this technology. Now, I think that regulators, they don't have like a lot of options at the moment. It feels like they need to leave the market to decide for them, because nobody, as I said earlier, understands the, let's say, the borders of this technology. I'm doing research on this topic, and it's really, really hard to find any kind of solid references on the regulatory frameworks. There are only predictions and only assumptions. Now, to what extent these assumptions are going to be, a reality, I think it will take a few years until we see an established framework that, based on which we can say that this domain is regulated. In my view, it shouldn't be so, because it's very hard to pin people down according to specific jurisdictions. The prime concern that I have personally is what Walid mentioned earlier, is about trust and security. I think these two concerns are much more important than implementing regulation that will eventually drag us back, because we want to move forward. We want to be able to innovate and create technology to help, to help services in general, and accountability and transparency. Yes, in brief, this is what I found so far, with regards to the link between blockchain, IG, and policy and regulation. There isn't much going on. Hopefully by the end of my research, I should be able to feed you with more information about it's not about the future, but what's going on, basically. Thank you, Walid.
Thank you, Hanan. It's quite insightful. The bottom line is that the subject itself is so fresh and so new that not many people understand how to deal with it legally and technically. Yes, we have a question from the floor. Feel free to ask or comment anytime. If there's a mic that can be used, yes.
As the last person commented, there's a lot of misunderstanding about blockchain. I think if we are talking about your concerns about regulation and governments, I think it mostly has to do with things that carry value in a financial transaction. I'd like to talk to you a little bit about an application that we're developing, where we are working with cooperating routers in an internet scenario with software-defined networking. And here, it's important that we can use a blockchain application because we have a number of independent actors who must cooperate to configure a network. And the question is, how do these actors trust each other? And here we have a model where we don't need to have a central point of trust, that is, for instance, a central certificate authorization or distribution agency, but each node can, using this blockchain technology, cooperate to validate and shall we say, come up with a new router or a new network configuration technology. And each of these routers can then agree, using this trustless technology of blockchain, that everyone has the same copy and understands the same new configuration for the network. So I don't like to confuse the matters more, but we can use blockchain technology where it's not a question of governments having to decide what policies they'd like to implement. There are applications for this blockchain technology in a trustless model which can have very many different applications.
Thank you very much for the comment. We have another intervention here, so if I get the mic, yes. Here we go.
Walid, I also have.
Thank you. I'm Auke from the Netherlands. My question is, could blockchain be a solution for fake news?
Interesting. I'm not sure if many people are ready to answer, but it's a good thought to consider. We have remote participants as well, I believe.
So this is from Nadira Al-Arash, and she was also on the organizing team for the session. Nadira writes, blockchain algorithms has its own embedded regulations through its coding and encryption techniques. This coding system enforces its own rules and regulations. I also think these set of rules do not actually comply with existing legal frameworks. Taking Bitcoin as one of the blockchain applications, in my understanding, some might classify Bitcoin as a commodity and others as e-currency. Based on this, where do governments discuss regulating Bitcoin? Do they discuss them under the Ministry of Finance or the Ministry of Commerce, for instance? The same logic goes for other blockchain applications. Is the trend to leave the coding to regulate itself?
Oh, thank you, Nadira. Thank you, Mike. We do have a speaker who's asked to speak, which is Arvin, and so I'll let him give him the floor for now, and then we'll resume a round of questions.
Thanks, Walid. Just wanted to, I'm Arvin from Diplo Foundation, and I'm working for these issues of blockchain and actual governance through a blockchain.
And a very professional miner, I guess.
Yeah, nah. Unfortunately, I'm not an early adopter, but I was an early promoter of this new technology. Just one small thing. Blockchain, as we know, was initial Bitcoin invention. It was invented in 2008 after the crash of financial crash in the Western world, and actually was a kind of a rebellion or a call for trust which will not be centralized. So we kind of lost the trust in our society, and we wanted to mathematically solve this in an elegant way. So this is how it is invented. It is original blockchain invention. So like it's original Bitcoin invention. So it needs to have that on mind. So through this convenient time stamping, we actually got one list or one chain which everyone can trust. So it is built, as Ken said at the beginning, it was built on peer-to-peer networks. Those are standards which are commonly used on the internet, and there are open standards. Bitcoin's blockchain is an open blockchain. Everyone can access it and distribute it, mine it, or other applications of blockchains can actually include the permission blockchains, which works in a system in which you can add additional layer of security, you can add additional layer of scalability, but those will be actually centralized blockchains. So we do have this promise of decentralization through a blockchain in a questions which we asked 10 years ago for the internet. Do we need a standardization? So then we realized we don't need standards kind of for pushing the internet. And we decided to go to the open networks, open standards, best effort, etc. So this notion of distributed trust is really something new. So how does the change occurs in this blockchain? It is by pure majority, like 51% of network is agreeing, going somewhere, they're going somewhere, that's it. So it's an emerged consensus. It's an idea of emerged consensus, which is not clear in which point it shows up, but it moves things forward. So if we thought 10, 15 years ago that for internet we need a multi-stakeholder advisory group, for example, for ICANN, so can we have something like that for the blockchain, but open blockchains? I understand that foreseeing the power of this new technology, many institutions, finance, others, have started to create their own versions. We heard one, we heard from Ken, many other applications of blockchains. But those distributed ledgers are quite different from this blockchain, Bitcoin's blockchain, and quite different from where everything started. So this is the question now, which road we will take, to be honest. So this is just one clarification. I see that many of you don't quite understand. Is it one blockchain, many of the others? But this initial blockchain, Bitcoin's blockchain, was made on an open peer-to-peer network, which are standards everyone used every day. Thanks, Kelly.
Thank you, Arvin. Very interesting thoughts about the subject. Yes, so we have one more.
Jacques Beglinger of Swiss Holdings, the Swiss Businesses Federation. And we assessed the situation together also with government sources in Switzerland. And what we come out with as a preliminary solution is, well, this is just a technology which can be used in different sectors. So any regulation needs to be done in the future in the light of the respective sectorial legislation. Taking Bitcoin, this is something clearly in our view which has to do with financial sector. So if it has an impact there, it should be regulated, but not as a distributed ledger or Bitcoin technology, but as a product afterwards, Bitcoin or any other cryptocurrency. And we also know that there are large companies having internal projects where this is not at all absolutely open peer-to-peer for everybody. That is a really closed circuit thing, and there it has nothing to do with regulation in our liberal sense.
Okay, thank you very much. Bernard, you wanted to add a comment? Yes.
Hi, I'm Bertrand Lachapelle from Internet and Jurisdiction. Thank you very much for the session, because it's illuminating for people like me who are not familiar at all on how it works. Two things. One, correct me if I'm wrong, what I understand from the last part of the discussion is that Bitcoin is one type of blockchain implementation, and that there are several implementation of blockchains under the label of distributed ledgers. That is a clarification that is useful for me. The second thing is the whole debate about decentralization. I think when you look at the internet, what we call the internet today is actually the emergence of those extremely large platforms that are providing a certain number of services. What I found interesting at the end of the presentation, at the beginning, before the game that was done, is the illustration of the large number of applications that can be done. Do you anticipate that on top of this technology, or leveraging this technology, it's actually going in the line of what was just said before, it's actually going to be a range of applications and potentially dominant players that will use a blockchain or a distributed ledger underlying technology to create dominant platform in one sector or the other. Is this going to be the main governance challenge rather than the regulation of the technology? And is that the right way to frame the problem?
Yes, let me answer first and then let Arvind continue. It looks like it's, we sometimes think that the internet is isolated from us. The internet, blockchain, all of these are purely human nature. I mean, they are a reflection of what we are. So there will always be very strong, powerful entities that call for control, keeping things in check. For example, governments would be concerned. One example is the ransomware. You recalled recently the attacks that happened, and the hackers actually used Bitcoin as a way for them to extort money, because it's not possible to trace where they are. So this is an example where governments would say, this needs to be centralized, this needs to be regulated. But it's not new. This has happened all the way from the very beginnings of the internet. When the internet emerged as a decentralized, distributed system, governments didn't take it really seriously, but after a while they realized, okay, now there's need to control or to at least regulate. And the same iteration, the same cycle is now happening for the blockchain. So I would totally think of it in the light of the human nature and how powerful entities would not want to lose power, would want to maintain some sort of checks and balances as they see fit, whether to protect national security, protect citizens, etc. So we are still at the very beginning of the stage. I'd say we are around the early 90s of the internet today when it comes to the blockchain. So the real momentum will start right now, and it's going to continue. So Arvind, would you like to add?
Yeah, as you said, as an early stage of internet, this is going to be exactly as you described, Bernard. It's going to be actually a battle for governance of other additional layers of this. Yes? So that's it.
Yeah. Yes, we have also remote moderator. Are there comments?
If I could just follow up, because it's directly related to that.
Yeah,
In
sure.
terms of dominant firms, though, it's also not only dominant within the application domain, but lots of the big firms are starting to offer blockchain as a service. And this is like infrastructure to try and all the major cloud providers are moving into this space as well. So that'll be quite interesting to see how that plays out. And also we're what's also interesting is you see the big four auditing consulting firms suddenly trying to also offer technology as a service where they hadn't done before. So I think that those underpinning platforms will be quite interesting because then people are building applications on top, and then that brings up a whole bunch of different concerns.
Yes, certainly. Thank you very much. Michael, you have your own intervention on this topic, yes?
Yeah, and if anybody knows me well enough, they should know exactly where I'm going with this, and that is that one aspect of governance that I think we also need to consider over time is the sustainability of blockchain, because right now, even on, for instance, the Bitcoin wiki, they address the ecological aspect of Bitcoin, the sustainability in terms of energy use. But when we're talking about blockchain, and that is that there can be so many different blockchains, and over time they're going to constantly, in 20 years, you'll go back and be able to find the first Bitcoin. If you multiply that by many, 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 many more blockchain applications, it could potentially end up using a lot of energy. So what the point is that I don't think energy was necessarily addressed whenever blockchain was first created, but as we move forward, this should be something that we incorporate as much as possible into the discussion. It's not to say that, by eliminating paper or by not using paper, we're saving elsewhere. It's not about net savings or anything. It's more about making it part of the discourse, period.
Thank you, Michael. There will always be questions and discussions when it comes to environmental implications of various technologies. But it looks like there are various groups that call for protecting, let's say, the infrastructure, the underlying infrastructure, so that it doesn't go too far astray and move away from the principles. Others call for various changes to the infrastructure or the original design of the Bitcoin. So there are various groups. If you might have heard, Bitcoin Unlimited is asking to expand the block size indefinitely so as to speed up the process of transaction verifications. Others, like the SegWit, which is the core protocol for reducing the size of the transactions that fit the block. So there are many ways in which they want to reduce the cost, but it's still an ongoing process. Yes.
Yes, Fabian Rosdalen from Sweden's biggest exchange company for Bitcoin, BTCX. And I want to point out that there are actually many in the field of cryptocurrencies. There are much more cryptocurrencies than Bitcoin as well, and also regarding like environmental and sustainable blockchains and so forth. We actually have a company in Sweden that has bought a big mining center, and they are using this to also, like, the heat that is generated through the mining center is also put into like heat up buildings and stuff like that. So I think there are very much like interesting implications of these kind of services.
Yep. Thank you. It looks like we are running out of time unless there's some pressing comment or question. Yeah. Yes. Yeah.
Just one very quick question. Given the way I understand the chain works, why is it necessary to keep the whole chain from day one instead of stopping it and overlapping? I suppose it's a very classical question.
Yes.
Basically, it's addressed in a paper made by Satoshi Nakamoto, the creator of it. So how can one system know what exactly is happening? By broadcasting everything which has ever happened. So just like that, just full control, full transparency forever. Everyone would be able to know whatever happened in this ledger. So it's just a ledger of things. That's why.
I mean, in other words, he would like to invent a way in which you can generate the whole blockchain from scratch, from very beginning. You can use it, have it all on your computer so that you know the first genesis all the way to now. Because if you take, let's say, the last 10 days, then the source, the last hash that you get for the last 10 days would be retrieved from someone. How do you trust if that stored data is correct or not? So that brings up the question of trust again.
Perhaps we need root servers for blockchain.
But Yeah.
Oh, really?
It looks like we're really running out of time. Some people have appointments, some others. What I invite you to do is that let's keep the discussion going. There's a wiki page open for members to discuss. The media wiki page of the session is actually open. So you can actually propose ideas, send us thoughts. Before ending, I'd like to thank very much the organizing team. Without them, this would have not been possible. Anton, I'd like to thank you very much. He is the one who generated the algorithms, the design, the graphs. Arvin, he's been very helpful from the very beginning throughout the design. Michael Ogea, of course, has been quite fabulous. Then we have people who are not with us, like Hanan, Nadira, and Renata, who were unable to make it. Their names are on the wiki. I'd like to thank you all for coming. And, of course, Ken Hansen, how can I forget? Ken Hansen and myself. And we all thank you for coming. I hope it didn't really disappoint. The next time it will be much more organized, maybe longer.